process that goes into the block diagram is called input, right? So anything goes into the block diagram is called input, and anything that goes out from the process is called output. The arrow is away from is called output. Am I right? Or sometimes it is called response. For the output, response or output. For the input, sometimes it is called set point. Set point. Sometimes it is called desired value. Sometimes it is called prescribed value, right? So those are what we call input or set point. Okay, guys, this is typical representation of any system for that matter, process or system. You can call this process or system or plant. Okay, for example, you have aircon system, you have robotic system, you have a vehicle system, and so forth and so forth. Liquid level system, spring damper system, and so on. Right. Okay. Now we take a look at a number of configuration that we can find, that we can see in the literature with respect to controller structure or controller configuration. I must say the first one, the A is the most common type that we can find in the real world as well as in literature. Okay, I should say the first one is the most popular type. Okay, so you have uh, in our study here in this chapter 6, we are focusing on feedback control system. We shall be doing design, yes, of course, design, but design for a negative feedback control system. Okay, can you see here? You'll find that the controller configuration for all those listed in this chapter, those listed in this book, right, will be based on negative feedback. Okay, so take a note, please. Negative feedback is the most popular structure of your controller system. Why negative? Why not positive? That's a question I'd like to ask you. Why do we use negative feedback, not positive? Anybody? You can answer this. Anybody? Why do we use negative? To achieve stability, not really, right. That one indirectly. I want more accurate answer, please. Hey, it's a good try, no doubt. Yeah. Okay, what else can you say, please? Yeah? Yeah, feedback signal, so what? It is feedback signal, so what? Feedback can be positive as well. Okay? Feedback can be positive, can be negative. So can you explain more? Why do we use negative feedback? Reduce amplitude of what? Amplitude of what? Okay, class, good try, but I want to be more specific. Not the noise. Yeah, the noise may be part of disturbance, not the gain. No. Okay, sudah, dah. Overshoot? No, it's not overshoot. Not the output. Okay, the answer is simple. Because we want to create an error. That's all. Because if you have error is equal to R minus Y. Am I right? Or normally I use U for your input, and I use Y for your output, right? So error is equal to U minus Y. So for negative feedback will result in error. Am I right? If you have positive, then you have U plus Y. U plus Y is not error. Okay, you can never call U plus Y as an error. But the difference in output and input, yes, you can easily say, yes, you can easily define it to be an error. Okay, so please guys, take a note. Why negative feedback? Because we want to create error, and most of this controller configuration, if not all, it is error driven. So E is error driven. What does it mean? Okay, it means error driven means the controller, more often than not, it will cause the error to become 0. So your GC, GC here is your controller, right? It will cause the error to become 0, so much so that finally, subsequently, your y is equal to u. All right, based on this equation, right? If error is equal to 0, then you have y is equal to u. So that fulfills the objective of any control system. What is the objective of any control system? You want your output, what you want to achieve, right? Equals to your what you set in your input. Okay, what you get is what you desired. In other words, am I right? So, for example, you want to control in your room the temperature in your room using air conditioning system, right? You want a temperature of say 24 degrees centigrade. So the aircon system will operate. You set 24 degrees as your set point, set temperature, right? So you will hear the compressor working. The compressor plus all the components in the air conditioning system, it will operate in such a way at the end of the day. Yes, it takes time. At the end of the day, you get your temperature in your room to be 24 degrees centigrade. Am I right? So you finally get your Y is equal to U. So I must say, the A configuration is most popular. And more often than not, I should say, this is called a PID control. Of course, sometimes it is you can apply also dead lag controller. I will mention later on. More often than not, this is called PID. What is PID? What does PID stand for? Proportional, integral, derivative. Am I right? Proportional plus integral plus derivative controller. Yes, in the real world, I should say more than 90% use PID. Okay. In the real world, real application, I'm saying about the real industrial controller, it will use this configuration. Okay. So it is called PID control. Later on, we shall see the equation involved. I think, in fact, this one you have learned in your controller action, right? In chapter 2, time response. Am I right? Okay, you are exposed, right, to the GC, the controller action, GC, proportional, integral, derivative. I'm sure of it, right? You are being taught the algorithm involved. Why PID is common? Yes, that's a very good question. Why is it is common? Because it is reliable. Okay, it is reliable. It is cheap. Don't say cheap lah, less expensive. Less expensive. It is relatively robust. Relatively robust. Okay, it is simple in structure. It is simple in structure, robust. It is linear controller. See, can you see all the advantages? And it is proven. It is proven effective. Okay, you can find that in literature. Yes, PID is dominant in literature. Why? Because it is proven to be effective. It is one of the controllers that has been studied studied um, uh, studied by many researchers. Okay, who invented PID? Okay, you ask Professor Google, who invented PID? Okay, all right. Okay, PID. Yes, there are too many literature. If you were to search in the Google, in the internet, for example, or if you go to library, you can find many good books on literature on PID. There you can find a lot of things. Okay, so yeah, PID is very popular because it is well proven. It is much research controller, right? And to the fact, in fact, it is sometimes called classical control. When people say classical control, it refers to PID. Classical, or sometimes it is called conventional. Okay, so when it's called classical or conventional, yes, normally it's called PID. And sometimes it is called three-term controller. The fact that it has been applied in the real world in many applications, especially in process control, chemical industry, where you want to control temperature, you want to control pressure, flow rate, all right, the pH content, and so forth and so forth. You see, so yes, it is widely used in industry, especially petrochemical industry, in process control industry, even in big plant. Once my ex-student, my former student, he worked in a steam power plant, in a power plant, in a power plant, and he told me, yes, PID is being used in a power plant. Can you see? To control certain parameter. So it's not a surprise thing, that you will find in the real world, in the industry, people still use PID control. Okay, so it's most popular because it is effective, proven effective. Right. So I should say A is most popular, right? Okay. One thing that I think I may add here, you can add another block here, and this block is normally associated with sensor. Okay, feedback element. Sensor is a feedback element, right? It measures the reading of your output, for example, and then send back to your input as comparison, as comparator, right? So that you can get U minus Y is equal to E. Okay, your sensor signal will give negative signal to obtain your error. Okay, so it's error driven, error driven, so that you can force the error to become zero by your controller. It is called also compensator or controller, so that at the end of the day you get your output is equal to your input. Okay, guys, is that okay? So this is, can you see single input, single output? When you say SISO, it's called single input, single output system. The one shown here is single input, single output. All right, same as your B. B is also another controller configuration, but this time it is feedback. Can you see? The controller is no more situated at the beginning of your block here after your error, but instead it is being brought at the feedback signal. See, this is being fed back. So your error is still here. All right. So this error plus your controller, then it becomes another control signal to actuate your process. Same here. Your E multiplied with GC, you will get your M. Okay. So your M actually equal to GC multiplied with E. Am I right? If your GC is K, only proportional element, then it will be M is equal to K E. Right. Okay, I told you it is PID, right? So in literature, you will find that there's a family of PID controller being used, extensively used. What are they? P. The first is P, proportional controller. Second is PI, proportional plus integral. The third is proportional plus derivative. Last but not least is proportional, integral, and derivative. Okay, so these four are the most popularly used uh, PID components, or you can say part of the PID family. Okay, the most common is P. Can you see all these four controllers? P is common, right? P is common. So you can see when you design a PID controller, make sure P is there. The P element must be there. The rest is optional. It's up to you to decide whether use P alone, PI, PD, or PID. Okay, guys, is there any other question? Okay, regarding who invented PID, I would like you to see for yourself, please, because it is, there are too many versions of who invented PID you can find in the literature. Okay, Irfan, is that okay? Right, okay. Right. Okay, so this is two configuration. We can look at others. The first one is called series compensation. B is feedback compensation, or you can say series controller, feedback controller is also okay, no problem. And note, there's only one controller for both system, right? For one controller, it is called 1 degree of freedom controller. Okay, if the controller contains more than one, then you say accordingly. If there are two controllers, then you have 2 degree of freedom controller. Three degree of freedom controller. For this case, 1 degree of freedom controller. And I should say mostly, if you were to see in the real world, yes, normally it is 1 degree of freedom because you want to make it as simple as possible. All right, so you one of the design procedure, try to start from simple things, and then you can build on. Okay, you can add on after that. Right. So that's the two configuration. We can see another 4 configuration here. Okay, C is called state feedback controller. Okay, D series feedback compensation, E forward series compensation, and F feed forward compensation. All right, guys. So there are this one. I just want to inform you, want to tell you that yes, in the real world or in literature, you can find many configuration, many controller configuration, but the most popular is A. All right, the most popular is A. All right, so you might have this okay, feedback, state feedback controller. You have K and C, state feedback. So feedback, why? Because K is situated at the feedback signal. Again, if you were to look at the feedback signal is always negative, but at the extreme outer loop. So most of the outer loop having um, okay, having negative feedback. Can you see outer loop? I'm not referring to the second loop or internal loop, but for the outer loop, more often than not, it is negative. As the reason is very simple. Why? Because you want to create error. Okay, you want to create error so that this error can be compensated later on by the controller. Okay, so and you will find that in your D, E, and F, they are 2 degree of freedom controller, right? A, B, C, 1 degree of freedom, but the rest, D, E, F, 2 degree of freedom controller. Why? Because can you see there are two? Like D, you have one located, yes, the series type, but the second is feedback type, right? So series and feedback plus. Okay, for the internal loop, control loop, it is not necessarily negative. It can be plus. Okay, it's only the outermost loop, which is normally you have negative feedback. Why? Because you want to create error. But the internal doesn't necessarily be error. It can be something else. It can be what shall we say, another signal, actuating signal, you can say complementing signal, etc. And for your information, my PhD research is on 2 degree of freedom controller, 2 degree of freedom controller with positive feedback. Okay, here it is show negative, right? But for my research, it is plus. I don't know if I have time, maybe I can show you the robustness of my controller when I did my research. Okay, but it's okay. All right. Okay. So the bottom line here is for you to understand that yeah, indeed there are many type of controller that you can find in literature. Okay, but the most popular I shall insist is the first one, A. A is the most popular, and that is the controller that we shall focus on until we finish our class for this chapter. Is that okay, guys? So we shall focus on PID controller, and we shall focus on root locus method to analyze, to design the control system. Right? So the design process involves modifying or compensating the performance characteristic of the system. So what you want to modify? Okay, normally we want to modify, when you say design, right? You want to set, you want to modify, you want to adjust. Adjust what? Modify what? Controller parameters. Okay, Okay, right. Example, your PID, right? In your PID, what we are interested in, we will be adjusting the proportional gain, and then the integral gain, KI, and your KD. KD is called derivative gain. So these are the controller parameters for PID. So meaning to say you have to modify, you have to set, you have to adjust KP, KI, KD in such a way you will cause the error to become 0 and that your Y is equal to U. Okay, is that okay, guys? So this is our objective. For any control system, you try to compensate, you try to adjust, you try to modify all the parameters, KP, KKD, or whatever other parameters that you consider in your controller, so that your E will approach 0, and finally your Y is equal to U. Your target is equal to what you desire, what you set. Okay, class, is that okay? I hope it is okay. Is there any question so far? All right, so yes, so for that reason, we have to design. Okay, here it is mentioned the most widely used controller in industry. Yes, it is rightly so. It is the PID. You can, if you want, you can circle this. You can highlight. The most widely used. I should say more than 90%. People use PID control. Why? Because I mentioned last time, it's simple, it's effective, it is linear, it is less expensive, it is quite robust. All right. It is non-model based and so forth and so forth. But of course, there are disadvantages as well. The main disadvantages of PID controller, you have to tune your KP, you have to adjust your KP, KI, KD so that you obtain a good combination of your KP, KI, KD. Okay, so the problem of tuning, so you have the problem of tuning your KP, KI, KD so that you can get your error approaching 0 and your Y is equal to U. All right, so this is important. You see that there are many advantages, but sometimes this tuning problem, sometimes it causes quite a hassle for the designer, for the user of the system. All right, okay. I mentioned to you, right? PID controller is the most commonly used, and so is the controller structure, right? Configuration A, right? And A as well is being used. Beside PID controller, you can use lead-lag controller. Lead-lag controller is like example, G is equal to 1 plus S over 2 plus 3S. Can you see? On top is lead, bottom is low. It is lag. Okay, so your GC can be lead-lag controller as well, beside the PID control. Okay, so beside PID is quite common as well, but not so common. You can use lead lag. So the third one is lead. The bottom denominator term is called lag term. So sometimes it is called lead lag controller. Okay, class. Right. Okay, is there any questions so far? So far, okay, Good. Okay, so we look at the design, basic design principle. Okay, yes, I did mention, right? In order for us to have a good controller, we should modify the performance in such a way. You have to modify, set certain parameters, controller parameters, so that your E will be approaching 0 and that your Y is equal to U. Am I right? Okay, that's the one of the basic principle. Okay, the others, if you have to design using, for example, you use root locus method, right? Okay, yes, you can see for yourself in this paragraph. Okay, guys, can we go out for a while and then come back again? I think my um, Webex is limited to I think 15 minutes. So can we uh, quit first and then we come back again? Is that okay? Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon. Okay, we have 5 minutes, approximately 5 minutes. Okay, I'll try to finish off 5 minutes and then we will proceed. We will stop here and then tomorrow we have our class tomorrow as well, right? So we will be having our class tomorrow. All right. I'm hoping 1 hour. 1 hour. Tomorrow our class is for 1 hour or so. 1 hour, 2 hours tomorrow. Class for tomorrow class is that for 2 hours or 1 hour? Oh, 2 hours. Okay. I tell you what. Okay, tomorrow our class starts at 9. Our class starts at 9. Okay, guys. Bear in mind, our class tomorrow starts at 9, so we'll do only 1 hour class tomorrow. Okay, this is to ensure that my class is synchronized. I've got 4 sections, and incidentally for this, we have some problem initially with my Webex, so I cut it short for one of the class, 2 hours. So this has to be synchronized with other classes. So other section shall also have 2 hours class for this week. Knowing that next week is our last week, is that so? Class next week is our last class. Is that so? Right, yeah. And I'm hoping after uh, after this class, before end of the week, I will give you the assignment. Okay, I will send the assignment via WhatsApp. Okay, assignment on possibly MATLAB. I think this one is quite simple. It can be done within short period of time. I give you 2 weeks for you to submit to me the uh, MATLAB assignment. Is that okay, guys? All right. Okay. So we go to basic design principle. So when you do the designing, right? When we design, okay, guys. I think something wrong with my mouse. I couldn't move my mouse. Okay, maybe this is for me to finish off for today's class. I think. Okay, guys, it's okay. I think we shall proceed with our class tomorrow's class. 9 a.m. in the morning. Okay, I'm just wondering, is it okay to start a bit earlier? We make it 8:45. Is that okay? because I think I have to finish off some part today, but I couldn't because of this problem. So tomorrow class we shall start at 8:45, not 9, eh? We start tomorrow's class at 8:45. Okay, guys, is that okay? I hope it is okay, eh? All right, good. So tomorrow 8:45 until 10, approximately 10. All right, and I will give you assignment hopefully within 2 or 3 days by WhatsApp, eh? I will send you WhatsApp on your assignment. Yeah, I couldn't move my mouse, you see. So yeah, so thank you very much for your participation. All right. Okay, take care about your health, please. All right. And do help your parents, your family, your siblings. So all the best to you. Okay. Assalamualaikum and a very good afternoon. Yeah. Okay.